Okay, so here's a difficult problem. Find the equation of line through point 3.5 that cuts off the least area in quadrant 1. All right, this is a difficult problem. First thing is to catch that this is an optimization problem. You're trying to minimize the area cut off in quadrant 1. And you have to have a picture here, I think, so you can picture it in your head. I plotted the 0.35, which we understand. And we know that there's going to be some line that goes through quadrant 1. And I'm going to guess about that steep. You go through the green point. All right? And we know that we're trying to minimize the area of this triangle. So we're going to have to write some equations here to calculate this out. We're going to have to know that this distance here is the x-intercept, and that's A. We're going to have to know the distance here is the y-intercept, and it's B. We're going to have to calculate. And I know that I'm trying to minimize that area. The area of that triangle is AB divided by 2. And that's what I want to optimize, capital A, the area. So I have to write some equations here, and it has to do with 0.35. I know the equation of the line, y equals mx plus b, general form. I don't know the slope, m, and I don't know the y-intercept, b, but I do know it goes through 0.35. So if I put those in, I can say, well, when y is 5, I would get 3m plus b as an equation. All right. I also know that when x is 0, we're going to get b as the y-intercept. And I got to figure out when y is 0, if I can get an equation here. So I would do that this time by saying, well, okay, I know 0 equals mx plus b. Don't know the x value, but that is the x-intercept for this one. So if I solve for it, I get negative b divided by m is going to be x. So this is negative b over m. Now again, you notice I have these points. So I know A, I know B here is distance B. I'm sticking with that. And I know A now is negative B over M. Still too many variables, but I think I'm going to be able to make the reduction here now. All right, and I did this by finding the intercepts, and I have this equation to fall back which relates M and B. All on my understanding of lines. Very complicated though. So if I extend the page a little bit, and I go down to 75% so we can kind of see, you know, make some space here. I'm going to go back to my black area. It was A equals little a times B, but now I can write negative B divided by the slope times B all over 2. And you might be a little bit curious and say, well, negative B over M, that doesn't make any sense. The slope's got to be negative, right? So that does make sense. Now, again, I can't optimize the equation with M and B. I have this little equation with the point. And I think I'm going to solve for M because I do not want, I have 2 B's already. So I'm going to solve for M here. And I'm going to get 5 minus B all over 3 is going to equal M. Well, I can plug that in this equation. And if I do that, I get A equals negative B over 5 minus B over 3 times B all over 2. All right, we got some cleanup to do. So the area is, this flips up to be 1/2. So I can say the area is negative B squared on the top over 2 times, got 3, negative 3 B squared over that. And right now, I can finally say, well, now I can optimize. I have the area of that triangle all in terms of the y-intercept B. And that's what I want to optimize, the position of B. And it's related to the line, and that's where the slope is buried inside this function. So let's find A prime, because we know we want to set A prime equal to 0. I'm going to use the quotient rule and write negative 6B times the bottom times 2, 5 minus B, minus the top times the derivative of the bottom, which is 2 times negative 1, all over the bottom squared, which is 4 times 5 minus b. I squared both things here. All right, well, I'm going to have to set this equal to 0, but to do that, I got to clean up the top. This is just some math stuff I got to do. I got negative 12b times 5 minus b on top, plus 3b, minus, I've got 3 negatives there, minus 3b squared times 2. So I'm going to get negative 6b squared on top, minus 60b plus 12b squared. And when I combine all my like terms in the numerator, I should get positive 6b squared then, minus 60b. All over still, 4 times 5 minus b, 20 squared. Now, you'll notice right away that this is undefined if b is 5. It can't be 5. If we go back, there's no way that the y-intercept can be 5, because if you do that, you'd have a horizontal line, and that would not make a triangle. It said the least amount of area, and that would be an infinite amount of area. So we're not worried about that, but we are worried where the top is equal to 0. So I'll write 6b times b minus 10 equals 0, the numerator factored. Again, b0 is not an option, but b equals 10 looks like an option. A y-intercept of 10. All right, and if you look at my sketch, it's about that, actually. So I want the equation of the line. Well, I just found that b equals 10. So I can now go all the way back up to my original equation. This is getting long, but I have this equation right here. I now know b is 10. So I will go with 5 equals 3m plus 10. Solve for m, I get negative 5/3, which makes sense. It had to be a negative slope. So now I have the two equations. The equation of my line is y equals negative 5/3 x plus 10. And that is the equation of a line that minimizes the area in the first quadrant. Again, a complicated optimization problem. Developing the equations is the key.